Alright, looking at exercise 5E, logarithms. As explained at the beginning of this chapter, the number 8 can be expressed in both the standard form and index form. So here we have the number 8. We can rewrite it as being 2 times 2 times 2, or simply base 2 to the power of 3, and this is known as index form. If a number is written in index, often called exponential form, then the index is called the logarithm or exponential. So we can refer to this as being the index or the logarithm. So here you can see base 2, and we can call this the logarithm, but more often it's called the power or the index. Let's look at this equation 1. Log base 2 of the number 8 is equivalent to 3. This means that the log of 8 to the base 2 is 3, or the log base 2 of 8 is 3. We've got equivalent statements here. 2 to the power of 3 is equal to 8, but an equally true statement is to say log base 2 of the number 8 is equal to 3. The general situation, a to the power of n is equal to w, log base a of the number w is equal to n. And just this little symbol here means equivalent statements, i.e. 2 to the power of 3 equaling 8 can be written as log base 2 of 8 equaling 3. In equation 1, 2 is raised to the power of 3 to produce the number 8. In equation 2, log base 2 of 8 is evaluated to establish 3, the index. The two of these equations have an undoing effect on one another. Other common mathematical undoing effects include, so these are inverse operations. 2 times 3 equals 6, 6 divided by 3 equals 2. Sine of 30 degrees equals 0.5, inverse sine of 0.5 equals 30 degrees. 2 plus 3 equals 5, 5 take away 3 equals 2. So these are undoing operations. We have various log laws, like we had index laws, and they are based, these log laws are based and proven with index laws. I won't go through the proofs, but I will state our log laws. Log base a of m times n is equivalent to log base a of m plus log base a of n. The second log law, log base a of m divided by n is equivalent to log base a of m minus log base a of n. The third law involves powers. Log base a of m to the power of n is equivalent to n times log base a of m. So in other words, what happens here is that the power just gets brought down to the front of the entire expression. If we have log with a base a of the number b, then we can say that this is equivalent to log of a particular or any type of base of b divided by log of that same base of a. This is quite helpful, although CAS calculators can work out any type of expression. If we have a scientific calculator, this comes in handy, and you'll see some examples of that when we're working through some problems. The fifth log law, log of base a of 1 is equal to 0. And it's just the reverse of our index law where we have a to the power of 0 equaling 1. Our sixth law, log base a of 1 on m is equivalent to having a negative log base a of m. Just makes that negative. Some other properties that are helpful when solving log equations, log base a of a to the power of n is equal to n. So in other words, if these two numbers here are the same, then it simplifies to being just n. Also, if we have a to the power of log base A of B, then we have just B as a result. So in other words, if we have a number raised to the power of log of that same number, so the A's here are the same as you can see, then it becomes just the B here.